Okay, this video is going to be over the classification of matter. You see this giant graph in your notes? Make sure you fill this out. This is a graph that's worth memorizing. So first off, we need to define what matter is. Matter is anything that contains mass and takes up space. That's your basic definition. So say you're given a substance and you're going to classify that substance into one of 4 different categories. It's a nice little flow chart to help you out with that. So the first question is, can it be physically separated? And our examples of physically separated is filtration, which would be through a coffee filter, or evaporation is letting the liquids just evaporate, just like water would, and leaving solid materials behind, but you can also go in and physically pick things up too and call it physically separated. If it can be physically separated, we call that a mixture. If it cannot be physically separated, we call it a pure substance. Now let's focus on the mixtures for now. Once you've classified it as a mixture, you have to ask yourself, is the composition uniform throughout? That means, does it look the same throughout the entirety of whatever piece of matter you're looking at? If the answer is yes, we're going to call that a homogeneous solution. So if you think of mainly liquids that look the same way throughout their entire bottle, some things that come to mind are soda. You have a whole bunch of different chemicals that are involved in making soda, and obviously they have that nice brown or black or white tint throughout them. You can think of tea, and then just about any chemical solution, because those look like water, but they have different things floating around in them. Now, if it was not uniform throughout, we call that a heterogeneous mixture. This should make sense if you remember your Latin from biology. Homo means the same, hetero means different. So a heterogeneous mixture is going to be something that does not look the same throughout. So if you think of something like gravel, you have different kinds of rocks inside that gravel. You have dirt, a bunch of different things just sitting in dirt that you can kind of pick up. Another good example would be something like trail mix. You have all those foods mixed together, but you can kind of pick and choose if you want the raisins or the peanuts or whatever you think is delicious out of trail mix. So this is a good little picture down here. If you look at the one on the left, you can see how the light kind of travels through that beaker. You can kind of see how it's kind of speckled all the way through that. That's not going to be a uniform composition, so that's going to be a heterogeneous mixture. Now, on the other hand, if you look at this one on the right, you can see that just looks like water. It looks the same throughout the entire beaker. So since it looks the same, we're going to call that a homogeneous mixture. So let's go back up to the top of our chart, and we start off with matter. Now our matter can be or cannot be physically separated. Once you classify it as a pure substance, you need to look at it and maybe even look at the chemical formula. Is it only made up of one type of atom on the periodic table? If the answer is no, we're going to call that a compound. So compounds are going to be H2O, it's going to be sugar. Anything that has multiple atoms involved with it, that's going to be a compound. On the other hand, if it's only made up of one different element, it's going to obviously just be an element. So that would be like chlorine, hydrogen, oxygen, things of that nature. So make sure you know this flow chart because it will help you out and it will come in handy. And you will see this chart again later on in the year. Let's go back and classify these a little bit more in depth. So pure substances, uniform, unchanging composition. A cool thing about pure substances is that they have exactly the same characteristic properties and composition. Every sample of it. So you can take a gallon of your pure substance versus just a little grain of your pure substance. They're going to have the same characteristics and properties. Now, elements. Elements are found in the periodic table. Obviously, you cannot separate elements into anything smaller. We'll find out later on that's not true. That takes a nuclear reaction to break them apart. We're going to focus on chemical reactions till the end of the semester when we talk about that. So elements cannot be broken apart, and they're found in the periodic table. That's what you need to get from that. Compounds, on the other hand, you see the baking soda down there. Combinations of 2 or more elements that are chemically bonded. So you see here we have a sodium, we have a hydrogen, carbon, 3 oxygens. That's obviously a compound because it's got more than one thing. Element would be chlorine, zinc, gold, something like that on the periodic table. Now mixtures. Mixtures are combinations of 2 or more pure substances. And then here's the key word. Each pure substance retains its individual chemical properties within a mixture. We'll talk more about that when it comes to solutions. But you have your 2 different types. We already talked about this. Heterogeneous mixtures are not the same throughout. You can see this is dirt there. You can kind of see this white piece up here, this white piece down here, a bunch of gray pieces. You can see how it's physically different. It does not have uniform composition throughout. Now homogeneous mixtures, there's your soda right there. You can see that the Mountain Dew's yellow, cola's brown, and then brown again. They look the same throughout. You can't pick out individual molecules from there just by looking at it. All right, so here are your answers. Check how you did. If you got them wrong, just go back through your flow chart.
Well, I sure hope nobody reads this.